All right, here is 9.2, getting back into parabolas. This lesson is going to expand on what you guys know about parabolas already. I'm going to teach most of the new material on the first few slides on Zoom, but I wanted to run through some examples with you guys here so that we're not on Zoom for too long. Okay, so all of this, hopefully you will have already had. This is also found in your textbook, but I'm going to go over that with you guys on Zoom. So here we go. Example 1. Example 1 from your homework is to write this in standard form and identify the vertex axis of symmetry and direction of opening of the parabola. Okay, so in order to do this, we need to review a little bit. So completing the square. Hopefully you guys remember how to complete the square. But we'll do it here in example 1, and hopefully that'll be good review for you. The standard form for this thing, so if we go back up to this chart here, notice here that we are dealing with a y equals. Okay, so since we're dealing with a y equals, we're going to be looking at the y equals part of the chart, because notice this part of the chart is a y equals, this part of the chart is an x equals. Okay, so we're going to try to get that equation into this form. All right, so here we go. In order to do that, a little bit of review on completing the square. Remember that with completing the square, we're looking for like a perfect square in the first term, perfect square in the last term, and then 2 times those 2 things in the middle. In order to complete the square, we often have to, unless they give us a perfect square, we'll often have to take this last term out. Okay, so what I do is I separate it. 4x squared plus 16x, and then I'm going to throw the 34 over here. Okay. Then what I do is I look here and see if there's anything that I can take out of these guys. And if there is, I take it out. So in this case, I have a 4. So I'm going to take a 4 out, and I'm left with x squared plus 4x. And then in order to complete the square, remember that it's always half of the middle term squared, and it will always be a plus. So it'll be plus something. And then here we still have our plus 34, but if I add something randomly into an equation, since these 2 things are equal, I have to subtract it if I'm on that same side of the equation here. You could also add it to the other side of the equation, but we want to keep it solved for y, so we're just going to subtract in this case. Okay, so here I'm going to take half of the middle term, which is 4. Half of the middle term 4 is 2. 2 squared is 4, so I'm going to throw a 4 in here. Okay, so after I've thrown a 4 in there, what I have to do is I have to subtract it out. But here's the tricky part. I didn't just add a 4 in, you guys. I added a 4 times 4 in. So I'm actually having to subtract a 16 here. All right, so now we can complete the square. So if you remember the pattern here, this thing will always factor to the first term, the square root of the first term, with this sign, so it'll be a plus in this case, and the square root of the last term, squared. Okay, so that's how completing the square turns into a perfect square there. And then we'd have to keep this subtraction going here. 34 minus 16 gives us 18, I believe. So we're going to still add in the 18. Once it's in this form, we know everything that we need to know about this thing. So they want us to identify the vertex. The vertex, once we're in this form, is simple to find. It's whatever makes this go to 0, which in this case is -2, and then this piece, 18. So the vertex is at -2, 18. Since this thing is opening up and down, since it's a y equals, the axis of symmetry will always be an x value. Okay, so the axis of symmetry here, and it'll always go through the vertex. So it'll go through the x vertex. So the axis of symmetry will be x equals -2. And since we have a positive number out front, this thing will open up. Okay, so that's the information that they want along with this equation for example 1. Okay, I know it's a lot of review and a couple of new things there. Notice that they're not asking us for the focus or the directrix or anything like that here yet. So that'll come a little later. Example 2, they want us to then graph one of these. So notice with example 2, this thing right now, if you were to try to put that in general form, there would be no h, no k. Okay, so if I see something this simple, I'm just going to make a table of values, x, y. I know that the vertex is at 0, since the h and the k are 0. So I'm going to put a dot there at 0. And then I'm going to just go to the right of that 0 and to the left of that 0. But remember, there's symmetry here. So if you know one side of it, you should know the other. Since the first term is positive, we know this opens up. Okay, so let's throw a 2 in there. If we throw a 2 in, 2 squared is 4. 4 times 2 is 8. Okay, so at 2, we're at 8. If you want to be sure, you can plug a -2 in. Make sure you use parentheses in your calculator. -2 squared is 4. 4 times 2 is also 8. So here at -2, we're also at 8. And those are really the only 2 points that I can fit on this graph, so I'm going to stop there. You could keep going, but we'll go off our graph. Okay, so that's example 2. 2a. 2b is a little more complicated, but notice they give it to us in a nice form. The standard form of this thing is very nice because it tells us exactly what we need to know. The vertex in this case, this is an x value here, so the vertex would be whatever makes that go to 0, which would be 1, and then this guy, -4. So there's our vertex at 1, -4. I'm going to go ahead and put that on my graph. The axis of symmetry here, since this is a y equals, it'll be an x equals, and that x value here would be 1. Because if the vertex is at 1, -4, and we know that it opens up, the symmetry line is going to run through the vertex. Okay, so once I've identified that, then I know that it's also opening up because the first term out here out front is positive, so this opens up. Okay, so now I can just use that information to start my XY table. All right, otherwise just random plugging points in, which is okay, but it's kind of hard to identify like where you need to be very clear where your vertex is and stuff like that. So here we go, let's plug this thing in. If I plug a 2 in, okay, I'm just choosing numbers on the graph there to the right of the axis of symmetry. If I plug a 2 in, 2 times 2 minus 1 squared minus 4 would give me 2 times 1 squared, which is just 1. 2 times 1 is 2. 2 minus 4 gives me the -2. So at 2, I'm at -2. And notice that's just 1 away from my axis of symmetry, so if I plug a 0 in, I should also be there. Okay. Then if I want to keep going here, I might plug in, this thing's going to be pretty narrow, so I'm going to try a 3. If I plug a 3 in, 2 times 3 minus 1 squared minus 4 would give me 8 minus 4, which equals 4. So at 3, we're at 4. That means at -1, I'm also going to be at 4. Okay, because this distance, the distance here in blue to that symmetry line has to remain the same, identical throughout. Okay, I think that's all the points that I need, so I'm going to just connect the dots here. Okay, that gives me a good rough idea of how this graph behaves, and we're done. All right, guys, I'm going to pause the video here, or stop the video here. We're only going to focus on the first 2 examples for now, and we'll do the second half of this lesson, example 3 and 4, next time.